Hello everyone, this is Sakshi and I welcome you all to my edutech platform Way to Learn. So today I'm going to solve some of the problems from mathematical physics. So it's again from complex analysis and it's counter integration. So we saw two types of counter integration in my last two videos. So it's turn to see the type 3 counter integration, which is the limits tends from minus infinity to plus infinity. So if you have an even function, then you can convert this limit as 2 into 0 to infinity. Okay, so let us see the steps to solve. These steps are the same as the previous one, like to find the poles and to find the residue and then use in the Cauchy residue theorem. So but here the poles should be okay, the poles that we are going to find in this limit, those poles should lie on the upper half of the complex plane or should lie on the purely real axis of the complex plane. So, and then next to find a simple pole, that is for you're going to get a simple. If you're going to get a simple pole, then you have to find the residue using this following formula. So I had given the residue, how to find the residue, like for simple pole and for order n poles. So you can check my video. The link will be in my description. So you can check that, and you're going to use this formula to find the residue. And then after finding the residue, you're going to use the Cauchy residue theorem, which is 2 pi I into summation r. So let us see an example and understand this. So if you have an integral like minus infinity to plus infinity 1 by x power 4 dx, I'm just substituting z instead of x. So I have to find the pole first. So my denominator should go to 0, which is 1 plus z power 4 equal to 0. So z power 4 will be equal to minus 1. So now I can write my minus 1 as cos pi plus I sin pi, or minus 1 is equal to cos 2n plus 1 pi plus I sin 2n plus 1 pi. So my z power 4 is equal to minus 1. So instead of that, I'm going to write e power I 2n plus 1 into pi. Now we can substitute n is equal to 0, 1, 2, 3, and we are going to substitute, like we are going to take like four values for n, and we are going to get the poles. So our poles will be z is equal to e power I pi by 4, e power 3 I pi by 4, e power 5 I pi by 4, and e power 7 I pi by 4. So I said that the pole should lie on the upper half of the plane. So if you calculate, like using cos pi by 4 plus I sin pi by 4 and cos 3 pi by 4 plus I sin 3 pi by 4. Similarly, if you calculate, only cos, that is e power I pi by 4 and e power 3 I pi by 4 will lie in the upper half of the plane. That is your this half. It should lie over this part of your complex plane. So if your pole lie on the upper half of the plane, then you're going to consider only those poles and you're going to take the residue only for those poles. So the two poles that are lying on the upper half are first one and the second one. That is e power I pi by 4 and e power 3 I pi by 4. So let us see our next step. We are going to find the residue. I told that we have to consider this formula to find the residue, that is psi of a by pi prime of a. So my phi prime will be, I'm differentiating 1 plus z power 4. I will be getting 4z cube, and I have to substitute my pole values. So on doing that, I get my R1 and R2, and then step 4 is to substitute in the Cauchy residue theorem, which is 2 pi I summation r. So on doing that, I get my summation, that is Cauchy residue theorem, will be equal to pi I by 2 into my poles. So after substituting the values for e power minus 3 pi I by 4 and e power minus 9 pi I by 4, I get my answer to be pi by root 2. I hope you understand this solution, and I'm going to provide you some of the important form like I provided you in my last video. So these are some of the important form which you can use it directly in any of your questions if they have this kind of form. So in my question, you can also use this first form, whereas here the interval lies from 0 to infinity, and my question has the interval from minus infinity to plus infinity. So you know that for an even function, you can change it to 2 into 0 to infinity. So when you do that and substitute in this first formula, you're going to get the same answer as I have solved. So these are some of the important terms, and just note this down in your formula notebook. And then let us solve a last homework problem, which was this cos 2 theta by 5 plus 4 cos theta, right? So we are going to solve by step that we have to substitute for d theta, then cos theta, and then cos 2 theta will be written as z square. And then you're going to change the interval 0 to 2 pi to closed intervals. So now after substitution you get this term. So on simplifying, I get my function to be 1 by I into z square by 2z square plus 5z plus 2. So here on solving the quadratic equation, I get my answer to be 2z plus 1 and z plus 2. So now you just remember that in this type of problem, we are going to consider the counter to be a closed circle of unit radius. So here the poles are z is equal to minus half and z is equal to minus 2. So z is equal to minus half lies inside and z is equal to minus 2 lies outside the circle. So I'm going to find the residue for only z is equal to minus half. So on finding the residue, this is a simple pole, so I'm just going to substitute in my simple pole formula and going to get the answer. So on substituting and substituting z is equal to minus half, I get my residue to be 1 by 12i. So the last step is to find the integral value by Cauchy residue theorem, that is 2 pi I into residue f of z. So 2 pi I into 1 by 12i will be 5 by 6. So it's your option D. So I hope that you like this video. So this is an important topic for mathematical physics, and keep watching. Stay tuned for more videos. So thank you. Like my videos, share my videos, and subscribe my channel. And also don't forget to hit the bell. So see you tomorrow. Ta-da!